Aeroplanes fascinate most of us. As a child, when you saw an aircraft in the sky, didn't you wonder what these aeroplanes are made of? Well, the time has come to resolve that mystery. Aircrafts are made of alloys which are lightweight and strong enough to withstand wear and tear. Aluminium-lithium alloys and the magnesium alloy known as electron 21 are often used to construct aircrafts. But lithium belongs to group 1 of the periodic table and magnesium belongs to group 2. Why do elements from two different groups show such similarity in their properties? Let's find the answer in today's episode. Hello and welcome. I am Devabrata Goswami and you are watching Chemistry. It is human nature to classify things according to their characteristics. We tend to find similarities in everything and then classify things accordingly. The periodic table is also an attempt to classify elements according to their properties. The periodic table is divided into 4 blocks. S block elements are those in which the last electron enters the outermost s orbital. Today, we will learn about the elements of this block. We will begin with the anomalous properties of lithium and beryllium, the diagonal relationship between lithium and magnesium, and between beryllium and aluminum. After this, we will discuss the variation in properties of group 1 and group 2 elements. And finally, we will look at some important questions in the exam decoded section. Before we begin, let me take you through the elements belonging to group 1 and group 2. The elements which belong to group 1 are known as alkali metals. Lithium, sodium, potassium, rubidium, cesium and francium are all alkali metals. Elements belonging to group 2 are known as alkaline earth metals. Beryllium, magnesium, calcium, strontium, barium and radium are all a part of this group. Let us start with lithium, the first element of group 1. Lithium is a very useful element. Have you ever heard of bipolar disorder? Bipolar disorder is a serious mental illness that causes extreme shifts in mood, energy and functioning. You must be wondering why I am talking about bipolar disorder in a chemistry show. Well, just plain lithium or lithium carbonate is used to treat this disease. It is thought that lithium may affect various chemicals in the brain called neurotransmitters. In fact, lithium is widely used in medicines for treating bipolar disorder. Lithium helps reduce its severity and frequency. I am sure you have come across people who stand out in their group. But did you know that some elements also behave differently from their groupmates at times? One such element is lithium. Lithium differs remarkably from the rest of alkali metals. We call this deviation from usual behavior of the other group 1 elements the anomalous behavior of lithium. Now, let us take a look at how lithium behaves anomalously. Lithium has higher melting and boiling points than other alkali metals, so it can withstand high temperature. Its compound, lithium stearate, is used for lubricating bearings in machines. Lithium ion is small in size and has high hydration enthalpy. If you recall clearly, hydration enthalpy is the amount of energy released when 1 mole of gaseous ions combine with water to form hydrated ions. Lithium ion and its compounds are more hydrated than the rest of the elements of the group. Take for example lithium chloride. Lithium chloride is deliquescent and crystallizes as a hydrate LiCl2H2O. Can you tell me how is this property of lithium useful? Keep thinking. Coming to the third anomalous property of lithium, lithium is the strongest reducing agent in its group. The standard reduction potential E0 lithium ion / lithium is minus 3.05 volts. And it is because of this property that it is used in lithium batteries, which are used in electronic devices such as cameras, clocks, and artificial pacemakers. We have discussed three anomalous properties of lithium. Lithium has high melting and boiling points. Lithium ion has high hydration enthalpy. And lithium is the strongest reducing agent in its group. Coming to the fourth anomalous property now. Lithium is a group 1 element, so its compound should form ionic bonds. But actually, its compounds form covalent bonds due to its small size and high polarizing power. Let us understand the last property by taking lithium chloride as an example. The lithium ion is small in size, so the tendency to distort the electron cloud of the anion by withdrawing the electrons from the negative ion towards itself is the maximum for it. Due to this distortion, the charges on the ions get neutralized, giving the bond a covalent character. Can you tell me why lithium shows anomalous behavior from the rest of the elements of the group? I will tell you. The anomalous properties of lithium could be attributed to its small size, high polarizing power, high ionization enthalpy, and non-availability of d orbitals. So that was about lithium. Now coming to beryllium. Just like lithium, beryllium, an alkaline earth metal, also shows anomalous properties from the rest of the elements of its group. Beryllium has a high melting point. This is the reason why beryllium is used as a refractory. Refractory is a material which has a high melting point, is resistant to heat, and difficult to melt. Beryllium is also used in the defense and in aerospace industries because of its high melting point. In fact, it was used to make the nozzle for Saturn V. Saturn V, popularly known as the Moon rocket, was a multi-stage liquid fuel rocket used by NASA's Apollo and Skylab programs earlier. Interesting, right? Coming to the second anomalous property of beryllium, unlike other alkaline earth metals, beryllium forms covalent compounds. This is because of beryllium's high polarizing power and small size compared to the other elements of the group. From this, we can deduce the reasons behind the anomalous behavior of beryllium: small size, high polarizing power, high ionization enthalpy, and non-availability of d orbitals. Apart from the anomalous behavior, there is another interesting property portrayed by the first elements of the two groups. They show a diagonal relationship with the second element of the next group. But while you are thinking this one through, let me give your gray cells some more exercise. Can you name the scientist who discovered the group 2 metal magnesium? You can find the answer to this and many more questions on www.topperlearning.com. So while you are exploring the site, we will take a short break. Welcome back. I am Deobrata Goswami and you are watching Chemistry. I had left you with a question before the break. Did you look for the answer? Yes? It was Sir Humphrey Davy who discovered magnesium. Now let's go back to the diagonal relationship. Even though lithium is an alkali metal and magnesium is an alkaline earth metal, they portray similar properties. If you look at the table, you will see magnesium is diagonally opposite to lithium. Therefore, this similarity is known as diagonal relationship. Beryllium and aluminium share a diagonal relationship. Do you know why? Well, let me tell you. Let's begin with the diagonal relationship between lithium and magnesium. Lithium and magnesium have the similar atomic and ionic radii. The atomic radii of lithium and magnesium are 152 and 160 picometer respectively. Also, the ionic radii of the lithium ion is 0.76 Armstrong and that of magnesium ion is 0.72 Armstrong. The similarity between atomic and ionic radii is because as we move down the group from lithium to sodium, the atomic radii increases, but also as we move from sodium to magnesium in the same period, the atomic radii decreases. So on moving diagonally, the atomic radii remains nearly the same. Let us now take a look at some properties in which lithium and magnesium show similarity. Beginning with their carbonates. Their carbonates decompose on heating to form oxides. Take a look. Lithium carbonate on heating gives lithium oxide and carbon dioxide, and similarly, magnesium carbonate on heating gives magnesium oxide and carbon dioxide. Also, both lithium and magnesium are harder and lighter than the other metals in their respective groups. This makes them ideal metals for aircrafts and airships. After studying the diagonal relationship between lithium and magnesium, let's study the diagonal relationship between beryllium and aluminium. Beryllium and aluminium do not have similar size, but the charge to radius ratio of Be2 plus and Al3 plus is nearly the same. Take a look at the graphic. You will notice that the chlorides of both beryllium and aluminium have bridged structures. So now you know about the anomalous behavior of lithium and beryllium. You also know why lithium shows a diagonal relationship with magnesium and beryllium shows a diagonal relationship with aluminium respectively. Now it's time to study some variations in properties observed by elements of these groups. Let's start. As you can see in the graphic, group 2 elements have smaller atomic radii compared to group 1 elements. I know that you must have some doubts by this stage, just like our caller here who has a very nice question.
Hello sir, I am Somil. I just wanted to know why magnesium chloride exists as hydrated magnesium chloride whereas sodium chloride exists in the unhydrated form.
That's a very good question. See, group 2 elements have smaller atomic radii and higher charge density compared to group 1 elements. And you all know, higher the charge density, higher is the ability of cations to attract water molecules. So, magnesium belonging to group 2 easily gets hydrated and exists as hydrated magnesium chloride while sodium chloride does not. I hope that answered your question. But now I have a question to ask you. Out of group 1 and group 2 elements, which group elements have higher electrical conductivity? Let me answer that for you. Group 1 and Group 2 elements have 1 and 2 electrons respectively in the outermost shell. So, Group 1 has 1 electron and Group 2 has 2 electrons available for metallic bonding. Therefore, Group 2 has higher metallic bonding. And the higher the metallic bonding, the higher is the electrical conductivity. So, Group 2 elements have higher electrical conductivity than Group 1. So, the variation in properties between the two groups can be summed up as Group 1 elements have a larger atomic radii and a lower electrical conductivity than Group 2 elements. Enough learning for today, isn't it? Well, if you have got all the concepts, you can pat your backs and take a short break and gear up for the exam decoded section. Welcome back. I am Deobrata Goswami and you are watching Chemistry 11. Let's begin with a short recap. The reasons behind the anomalous behavior of lithium and beryllium are small atomic size, high polarizing power, high ionization enthalpy, and non-availability of d orbitals. The similarity in properties of the first element with the second element of the next group present diagonally is called diagonal relationship. Group 1 elements have a larger atomic size and lower electrical conductivity than Group 2 elements. Well, now that we have all the fundas, let's take a look at exam decoded. Welcome to Exam Decoded. I hope you are all geared up. I am going to ask you some easy questions and you have to answer them within 5 seconds. Ready? Here is the first one just for you. Which of the following elements belong to Group 1? A. Magnesium, B. Strontium, C. Radium, D. Lithium. Lithium belongs to Group 1. So the answer is D, lithium. Here comes the second one. Lithium and beryllium show anomalous behavior because of A. Low ionization enthalpy, B. Large size, C. Small size, D. Low melting point. If you have been paying attention, you will know that the answer is C. Small size. Let us quickly volley in the third question. Beryllium shares a diagonal relationship with A. Lithium, B. Magnesium, C. Aluminium, D. Silicon. Beryllium shares a diagonal relationship with aluminium. So, the answer is C. Now tell me, lithium chloride is purely an ionic compound. True or false? It is false. Lithium chloride forms a covalent compound. Name the element which is found in beryl, which is considered a gemstone. A. Lithium, B. Sodium, C. Beryllium, D. Strontium. And the correct answer is C. Beryllium. That was a good rapid fire round. I hope you did well. The questions were easy. If you got all right, then you are a high flyer and you must give yourself a big hand. If you scored between 3 to 4, you are an achiever and a bit more effort will get you to the top. So good going. And if you have scored below 3, then you need to revisit your concepts. Don't worry, www.topperlearning.com is there for you, so you can post your queries and have our experts answer them for you. Moving on to the kind of questions that are asked from this chapter, Questions from this chapter are usually short answer type for 1 or 2 marks. Conceptual and knowledge-based questions are asked from this topic. But now that you are well versed with this topic, you have 5 marks in your hands. Having given so many exams till date, you are aware that merely clear concepts don't fetch marks. Presentation is equally important. So, take note of how I answer this question. Explain why group 2 metals like magnesium and calcium are harder than group 1 metals like sodium and potassium. This question is for 2 marks. Here is the answer. Group 2 elements have stronger metallic bonding than group 1 elements. This is because they have 2 electrons in the outermost shell. This statement will fetch you 1 mark. Stronger is the metallic bonding, more energy is required to break the bond. Thus, harder is the metal. This will fetch you another 1 mark. This is why group 2 elements like magnesium and calcium are harder than group 1 elements like sodium and potassium. Now that you have a clear idea about how questions from this chapter should be answered, take a look at what our expert has to say.
Group 2 elements are also called as alkaline earth metals. They form di-positive cations as they have electronic configuration of Ns2. They show an oxidation state of +2 and their atomic sizes will increase down the group. That means beryllium will have the smallest size and radium will have the largest size. From examination point of view, students should pay attention that alkaline earth metals are less reactive as compared to group 1 elements. But the questions can be asked on the basis of decomposition reaction, ionization enthalpy or the stability of compounds formed by group 2 elements.
I am sure today's topic solved a lot of questions that must have arisen from the use of lithium and magnesium in planes and other transport vehicles. But before I sign off, I have a question for you. Have you ever wondered why sand is used to extinguish fire during wars and not water? Well, you can always look up the answer on www.topperlearning.com. Happy searching. Here is Devabrata wishing you all the best.